Welcome to Skills and Academic Tuition Center. In this video, we are going to look at another important concept in physics, and that is analyzing the electrical circuits. So there are two important electrical circuits, and that is the series circuit and as well as the parallel circuit. So we have to understand what a series circuit is and the calculations that are involved in the series circuit, and as well as understand the parallel circuit and also the calculations that are involved in parallel circuit. Okay, so we are going to start with the series circuit. So in a series circuit, the components are connected end to end in order to provide or in order to create a single path for current flow. So in a series circuit, when we talk of these components, we are simply talking about the resistors and as well as cells and other components that might have been connected in a series circuit. So in a series circuit, the components are connected end to end in order to provide a single path for electric current, for current to flow in a single path. Now let's try to look at this example which we have here. So we have the cells at this point. So these cells are acting as the source of energy. Then we also have the ammeter here. As usual, the ammeter is used to measure the electric current. Then we have these two, which we are calling as the resistors. Then we have the voltmeter, which is used to measure voltage. So there are three important rules that you have to understand whenever you're dealing with a series circuit. So rule number one is that the current flowing through the conductor is same at all points. So the current that is flowing through the conductor is the same at all points. So for example, if we have a current of 2 amps flowing in this particular conductor, this same current will be the same at this point. We'll have 2 amps. Then even there, we're going to have 2 amps. Then even as it leaves this other side, we are going to have 2 amps. So very important rule in series circuit, the current is the same at all points. The second rule is that the sum of the potential difference across the resistor is the same as the potential difference that is provided by the batteries. So the sum of the potential difference, so here we have 2 resistors. So when we add the potential difference across these 2 resistors, what we are going to have will be equal to the potential difference across the battery. So the third rule is that the sum of the individual resistance is equal to the combined resistance of the component. What does this mean? So for instance, if we have resistor 1 here, then this is our resistor 2. So we're saying the sum of the individual resistance is equal to the combined resistance of the component. So if this resistor 1 is 2 ohms, then this resistor 2 is 3 ohms. So our combined resistance will be the sum of the individual resistances provided by the resistors. So in our case, we are going to have R1 plus R2, and this will give us R1 here. We are going to put the 2 ohms. Then R2 will be 3 ohms. So our combined resistance in this case is going to be 5 ohms. So this is the combined resistance. So that's why we are saying the sum of the individual resistance is equal to the combined resistance. So now, in such an arrangement or in a series, the combined resistance provides a higher resistance as compared to the individual resistance. So the combined resistance provides a higher resistance as compared to the individual resistance. Okay, so let's try to look at this example. So in this example, a 3.0 volts supply is connected to two resistors. So what we have here, when you look at this diagram, we have, you can say this is R1, and this is R2. So our resistor 1, resistor 2, and then we have the ammeter here. So just by arrangement, the resistors are arranged in series. Resistors are arranged in series. But the question is, what is the total resistance? What is the total resistance in the circuit? So in order for you to get the total resistance in circuit, you are going to say total resistance is equal to resistor 1 plus resistor 2. So our total resistance is equal to resistor 1, which is this one. It's going to be 2 ohms. Then resistor 2, we substitute, which is also 2 ohms. So therefore, the total resistance is 4 ohms. So that is our total resistance. So when we add the two, we get the sum of the two in order for us to have a combined resistance or the total resistance. We look at the other question, which is saying calculate the ammeter reading when the switch is closed. So when you close the switch here, meaning you switch it on, what is going to be the ammeter reading? By the ammeter reading, you are calculating the current. So in short, what is the current in the circuit? So for you to get the current, we can write down our data. So we say current, that is what we are calculating. We don't have the current. Then you can say voltage, we have 3.0 volts, and we have resistance, which is 4 ohms. So we have used 4 ohms because we are calculating the current for the circuit, the current that is flowing in the circuit. We are not calculating the current for a particular resistor. So whatever current we are going to get will be equal at all points, if you remember amongst those rules that we looked at. So here we are going to use 4 ohms because that is the total resistance in the circuit. So now we say current is equal to voltage divided by resistance. Current being equal to voltage divided by resistance. Equal to, so we say where there is the voltage given in the circuit, which is 3.0 volts, then divided by the resistance, which is the 4 ohms. So when you say 3.0 divided by 4, so when you do your mathematics, you're going to have 0.75 amps. So this is the current that is flowing through the circuit. Thank you for watching. Value for education, our pride.